Hello, I'm Colin from We Learn to Share, and today's lecture is about stoichiometry, or the mass relations in chemistry. Unlike our last chapter, this one does not require a lot of memorizations about its contents, but it is important to fully understand the calculating processes, since chemistry is quantitative science, and your skills in stoichiometry will enhance the solving speed of almost all chemistry problems. As we learned in our last lecture, Avogadro's number is an important counting unit for scientists. This quantity, 6.022 times 10 to the power of 23, is given a special name, the mole. A mole can also be used to represent the mass of a given molecule, and the molar mass in grams per mole is the sum of atomic masses to the atoms in the formula and is equal to the quantity. When converting moles into grams, we can multiply n, the amount of moles, with mm, the molar mass of a substance, to obtain the mass of a given species. Conversely, the molar mass can be used as a conversion factor in calculating the number of moles from masses. Moles can also be used to indicate the concentration of a solution. The amount of solute in a given solution, in moles, per given the amount of solution in liters, is the molarity of a solution. These symbols can be used to represent the molarities of substance A in solutions. Conversely, molarity can be used to calculate the amount of substance with the required volume. When ionic solids dissolve in water, the cations and anions get separated, and in these cases, we can determine the amount of each product using the chemical equations. The percent composition of a compound can be specified by citing the mass percents of elements present. For example, the percent composition of potassium chromate is 40.268% potassium, 26.776% chromium, and 32.956% oxygen. The percent composition of a compound can be used to determine the simplest ratio between the atoms of elements, and therefore we can find out the simplest formula. The simplest formulas can be multiplied to obtain the molecular formula of a product, but to do this, it is necessary to know the molar mass of the compound. There are a lot of problems involving the simplest formula, so make sure you review the textbook and get used to the term. Let's go on to our last part, writing and balancing chemical equations. This process is highly important in chemistry since any calculation involving a reaction must be based on the balanced equation. To do this, we need to go through these 3 steps. First, we need to write a skeleton equation with the molecular formulas of the reactants on the left and those of the products on the right. Second, we must write down the physical state of each reactant and product. Third, we need to balance the equation by adjusting the coefficients in front of the formulas to match the number of atoms for each element on both sides. After ending this process, the equation can be used to obtain many things. For example, the coefficients of a balanced equation, the ones we wrote in the 3rd step, represent the numbers of moles of reactants and products. The amount of the product that can be obtained under certain conditions without the loss of reactants is the theoretical yield of the product. In a laboratory, reactants are not present in the exact ratio required for the reaction, and one reactant is in excess, so there are some amounts remaining after the reaction is completed. The other reactant is called the limiting reactant, and it is completely consumed to give the theoretical yield of the product. In real-life reactions, however, the obtained product usually does not match the theoretical yield, since many factors, such as the competing reactions of the limiting reactants or loss of products, lower the actual experimental yield. The percent yield is the ratio of the experimental yield to the theoretical yield, and is always less than 100% because of the reason. This is the end of today's lecture. It may have been short, but do not underestimate the significance of stoichiometry. Don't forget to review and try to solve at least half of the questions and problems in the textbook. Get familiar with the terms and enhance your calculation speed. Our next lecture is about gases, and we'll skip chapter 4 for now, since it's closely related with the chapters of the end of the curriculum. If you want to continue your journey of general chemistry, please subscribe to this channel, leave a like, and turn on the notifications.